So you've noticed I've done a lot of videos on memory, and we've done the one on the pointer so far. And so this is a little bit of a complicated topic. So don't worry, not every topic is this complicated, but I want to make sure that you have all the proper tools for understanding computer memory and dealing with pointers, because we'll deal with pointers once we actually get into data structures. Okay, so this is our example from earlier when we have our addressing. And so in the first video we spoke a little about memory, and then in the second video we showed some C++ examples, and in the last video we spoke a little bit more about memory and pointers, and the example of the difference between what's contained in a memory address and any variables that are pointing to that memory address. And so now we actually move to using and understanding pointers. So let's declare a pointer. So we've got our integer I, and then we've got our pointer to p. And so right now p doesn't contain anything. And then so in here we say I equals 5, and then we say that p equals the address of I. And so I'll run through some examples and kind of hit this from a bunch of different angles, and maybe it'll hammer it in a little better here. So let's say let's add another line here that says value of star p. And remember from the last video, that's our dereference operator. And then we will dereference it. And then we'll compile this and make sure that I did not give you a bad example. Okay, let's put a space there so it makes a little more sense. Okay, so from one of the previous videos, we have the value of I is 5, which is fine. The address is, and then some address. We don't really care so much the number of the address, only that I should say we don't care about this specific number, but that there is an address, and we have a way of knowing what that address is. And then we say the value of star p is 5, and that what that does is that actually is our dereference operator. So we go to that spot in memory and we ask the computer what's in this memory address, this big long number right here, and the computer comes back and it says that it is 5. So let's continue on. Okay, so now we have our address of p, and this is a little interesting because not only can we dereference it, but p also contains an address and what the actual address we're pointing to, and the address is ampersand I. And so let's run this. And as we can see, these addresses actually match. So what we're saying, the address of p, which is our pointer, which is a special thing. It's not exactly like our regular variable I that we deal with. But so we've got a address here, and it's the same, so that's good. And we can actually use that address operator. And don't worry too much if you don't completely understand what's going on here. But a pointer itself has to have an address, because what we're saying is we're going to point to something. So even the pointer itself has an address. And so that may seem a little strange, but every time you write something in your program, it's got to be stored somewhere, and that place is memory. So when we make a pointer, that pointer contains an address, and the pointer itself even has an address. So we run that, and then we can see the pointer itself has an address. But just to note, as a practical matter, you don't tend to almost ever use the actual address of the pointer itself. What we do is we use the address of the thing the pointer points to. So we're more concerned about the the useful memory address, not so much the address of the pointer. That's kind of, I don't want to say useless information, but as far as this course is concerned, you're not too concerned about it. But it's just a little neat thing to know that really anytime you do anything on a program, it's going to sit in some place in memory. And this is actually sitting on something called a stack. And the reason the memory address is so high is because the stack grows from the bottom of memory and goes up. And there's also some other considerations. It needs to be a power of 2, and it's usually depending on if you're a 32-bit or 64-bit, it'll be some multiple of either 64-bit or 32-bit, and there's some other considerations. So this is all kind of interesting stuff, but really we're only concerned with the first 4 lines. So we have our automatic local variable that sits on the stack, which is going to be 5, and we have its address, and then we have our pointer, which knows how to point to that, and then we have the address that it's pointing to, which matches that. So let's have a little fun with this. So say we start to change things. So now instead of I equals 5, we say I equals 7, and then we let's actually do this. Let's put some extra new lines in here, and then so that'll make this example a little. And you know what? We really don't need this one. This one was just kind of to show a point that doesn't really affect the course a whole lot. So we just have our 4 lines. We have our local variable and our pointer. And so we've said now that I equals 7. So I didn't really change the memory address that I is coupled with equals 7. So now when we run it the first time, everything should equal 5. And then the second time, all the memory addresses will be the same, but the value will change. So let's run it so you know that I'm not lying to you. Okay, so in the first one we have 5, and then it has some memory addresses, and now we've changed the value of I is 7, but it points to that exact same memory address. And what's interesting to note is we didn't really change P, but because P is a pointer and it's pointing to a memory location, its value is 7. And then so we can see that the addresses are all the same. And then so now a new thing we can do in a similar respect is what if we were to actually change the pointer? So we say star P equals, and now let's give it a new number, let's say 9. And then so now when we run it, we can see that in our first set of print statements, our couts, that we went over, we have a memory address and we have a value. And you notice in all 3 of these that the memory addresses are the exact same. And then we have 5, and then in the second example we changed it to 7 by changing I. And in the third example we actually changed star P. And what you can notice is that I changed as well. And I shouldn't even say that I changed so much as the value contained in its memory address changed. So hopefully that all makes sense, and send me any comments if you have trouble seeing this on the videos, or if the videos are too loud or too soft, or if I go too fast or too slow, or any other considerations, because I want to really make sure everybody understands memory addressing and pointers, because it's a pretty important topic when we get into data structures.